Hello everyone, welcome to another video of General Understanding. In today's video, we'll be going over molecular interactions in the introduction of it, and these slides were made by me, Vishal, Surya, and Ethan Sun. So first, we're going to go on to covalent bonds. Sorry for the animation there. Covalent bonds are the sharing of valence electrons between atoms. Single bonds are whenever one pair of electrons are shared between the two atoms, and double bonds are where two electrons are shared between the atoms. In bonds in general, an atom will want to fill up its valence shell, and they are more reactive the closer they are to doing so. In the valence shell for any other shell other than the first one is always 8 electrons, and for the first orbital shell it's always 2 electrons. Let's look at an example in H2O. In water, hydrogen needs to add one more electron to its valence shell, and the oxygen needs to add 2 more electrons to fill its outer shell. So it makes sense whenever you think about it, because when hydrogen needs one more valence electron to fill up its 2 electrons, it will take one from the oxygen and share that. And the same goes for the other oxygen and the other hydrogen and the oxygen. So next, we're going to go on to the types of covalent bonds. Before we get into the types, we need to discuss electronegativity. Electronegativity is the attraction between the atom and the electrons it's bonded with. First, we're going to go on to polar covalent bonds. The electronegativity of the atoms are different. An example is in water. Oxygen is extremely electronegative, and the electrons being shared spend most of their time in the oxygen orbitals. Secondly, is nonpolar covalent bonds. The electronegativities of the atoms in these bonds are the same. An example is H2. The electronegativity of hydrogen and hydrogen are the same, obviously. Here's a picture, an example right here. This is the delta sign. Okay. Next, we're going on to hydrogen bonds. Hydrogen bonds are a type of weak interaction between molecules. They happen whenever a hydrogen atom covalently bonds to an electronegative atom. An example is water, because oxygen is electronegative. The electropositivity from the hydrogen then allows it to bind to another electronegative atom. The two usual electronegative atoms that hydrogen bonds to usually are oxygen and nitrogen. Next, we'll go on to ionic bonding. Ionic bonding is formed by the transfer of electrons from its valence shells, rather than sharing of electrons. This basically means electrons are being stolen, rather than shared in covalent bonds. So going on to this, bonded particles will have a full valence shell, and they will have an electric charge, either positive or negative. The atom giving away its electron becomes a positively charged cation, whereas an atom accepting the electron becomes an anion. So cation means positive, and anion means negative. Some degree of covalent bonding is inevitable, however, it is outweighed by the ionic character. You don't have to worry about that too much, however. So in solids, it forms a crystal lattice structure, as you can see right here with NaCl. So the Na, right here, the sodium, has one extra electron. It will transfer all the way to the chlorine. And this is how it goes. The sodium is now sodium ionic cation, and chloride is now an anion. Now, finally, to end this up, we're going to go in ions in a solution. Ions tend to dissolve in polar solutions, such as water, and ions dissociate, and the crystal lattice structure will break down. Then, in aqueous solutions, or in solutions that have water, or that are water basically, they will form hydration shells, as you can see right here. So, hydrogens with the partial positive will face the anions right here. You can see the hydrogens will partially positive, and they attract to opposite the chloride. But oxygen is electronegative, and it's going to attract to the sodium ions, which is positively charged. So these dissolved ions are called electrolytes, which gives water its conductivity. So in a later video, we're going to go more into the types of ionic bonds, but we couldn't do in this video due to more time constraints. So overall, if you made it to the end of the video, thank you so much. Please like and subscribe as always. I'm going to do a fun little thing that my good friend Gerard did in his videos when he was back on the channel, so shout out to him. This was his idea. Whoever has one of the best comments related to the video will get shouted out in the next video in the biology series, and the best comment will get pinned. As always, please like and subscribe with post notifications so you never miss a video. Also, your subscription really means a lot to us, as we're currently on the grind for 100 subscribers, and a special most likely be coming if we do this. So, thank you for watching this video.